Let's take a few minutes to solve literal equations. A literal equation is just an equation with more than one variable in it. So we'll start with a problem that looks like this. It will be Rx minus 3a equals t squared. And you do need to be told what variable you're solving for. Solving for x is quite different than solving for a or solving for t in this problem. I'm going to say for this problem we'll solve for x. Notice with respect to x, this is a linear equation. In other words, what I'm saying is that this x right here is to the first power. So we're going to treat it like any other equation, just like I would if I had an equation that looked like this. If I had a 5x minus 3 equals 11, you know you would add 3x or add 3 to both sides first to help isolate the x. So similarly on this problem, I'm going to add 3a to both sides. And when I do that, my equation becomes Rx equals t squared plus 3a. And I need to take care of that r. So let's divide by r. Remember, the goal is to have just x equals some expression. So when I divide the left-hand side by r, the r's will cancel. Now when I divide the right-hand side by r, I'm going to divide the whole thing by r. Nothing will reduce. So I have x equals t squared plus 3a divided by r. And our problem is complete. Let's do another one. Let's let the problem look like this. It will be mx squared plus n plus 1 equals nx. And for this problem, let's solve for n. And notice that the n exists in two places. It's right here and it's right here. And notice each of those n's is raised to the first power. So I'm solving an equation that's linear with respect to n. That means I need all the n's on one side and all the terms without the n on the other. So let's put the n's on the right-hand side, and I'm going to do that by subtracting n from both sides. So my equation now looks like this. Mx squared plus 1 equals nx minus n. So it's exactly what I was looking for. All the terms without the n are on the left, and all the terms with the n are on the right. But notice the terms on the right are not like terms, so we can't add or subtract them and put them together as one. But we can factor out the n, and that's the key for this problem. Let's factor out the n, and we'll have x minus 1 in the parentheses, and on the left-hand side, we'll just have mx squared plus 1. So to finish, we're going to divide both sides by x minus 1, and that will isolate our n. The x minus 1's cancel on the right, so I have n equals mx squared plus 1 over x minus 1. And we have finished solving for n. Let's look at one more, and I want to keep it on this same page because I want you to see how similar the problem looks. The directions will be to solve for x, but the equation will be the same as the one we just had in the previous problem. It is mx squared plus n plus 1 equals nx. So if we're now solving for x, we need to notice that we have an x to the second power here and an x to the first power here. So this problem is quadratic with respect to x, and that changes what we do. We're going to need to set this problem equal to 0. So let's do that by subtracting nx from both sides. Now I want to put that term here in the middle because I want the x squared term first and then the term that contains the x and then all of the terms that are without an x last. So our equation becomes this: mx squared minus nx plus n plus 1 equals 0. And you could try to factor this problem. You'll just find that it doesn't factor. And the square root property doesn't look good. And although you could use completing the square, I wouldn't. It would be fairly complex to use that strategy. So that leaves the quadratic formula. So let's identify A. A is your coefficient of your x squared. So in this case, m. Let's identify B. It's the coefficient of x, in this case, the opposite of n. And we need to identify C. Our C equals n plus 1, those terms that are not coefficients of x or x squared. So we're going to put those into our quadratic formula. So we have x equals the opposite of B plus or minus the square root of b squared minus 4 times a times c. And take care with that c. We recognize there are two terms, so we need to put it in parentheses. And we're going to divide by 2a. And then we need to do any simplifying that's possible. So underneath the radical sign, I do have some things I need to do. So we have n plus or minus the square root of n squared. And now let's distribute the negative 4m. So we have minus 4mn minus 4m. All of that divided by 2m. And this is complete. Notice we cannot take anything else out from the radical because we do not have a perfect square factor underneath that square root sign. We have an n squared, but that's being added to something. It isn't a factor underneath the radical sign. So this problem is done.